All right, lesson 8 in module 6 is on informally fitting a line. So what does that mean when we're informally fitting a line? Well, remember we've been working on scatter plots, and scatter plots, well, they don't lie on a perfect line. So what do we do when we want to talk about relationships and want to make predictions and everything? We're going to actually be drawing in a line, fitting a line, or what's sometimes called a line of best fit or best fitting line. Okay? So it says, let's look at some data from one Midwestern city that indicate the size and sale prices of various houses sold in the city. All right, um, so these are Midwestern, kind of around our area somewhere, I guess. A 5,232 square foot house would be $1 million. A 1,875 square foot house would be almost 180,000. Okay, so looks like it's Milwaukee area here, right? So this is the size and this is the price, okay? And you're welcome. We don't have to plot the points. It's already been done for us. So you can see that 5,200 one, it's up here over $1 million, okay? That 18, be about right here, 75, 179, will be right in here, okay? So it says, what can we tell about the price of large homes compared to the price of small homes from the table? Well, as always, pay attention to our axes. Okay, size of the house is on the x-axis, and how much it costs is on the y-axis. So what can we tell about the price of a large home? Well, as the size of the house is increasing, in general, step back. Don't play connect the dots. What seems to be happening to our price in dollars? Well, but this is going up, but then it comes back down. Does that mean there's not a relationship? No, we're not worried about one dot or two dots, but we want to look at the big picture. And I have to pause for a second. I'm getting ahead of myself. We want to take it from the table. Okay, so notice I went to the graph right away because it's way easier on the graph. If we look at our bigger houses here on the table, like this one, obviously $1 million, that's the biggest price. Here is one that's over 4,000 square feet. That's almost $800,000. Here's another 400,000 square feet, between 650, 700,000. Okay, so from the table, I can kind of just glance and say, hey, well, this one, oh, less than 1,000 square feet. That's not priced very much. So we can get this information from the table, but again, you'll notice I went right to the graph because it's easier to see. So we're going to say larger homes tend to cost more than smaller homes. 10. You're going to see I use that word a lot because it doesn't not always the case, okay? But they in general do, right? So now to the scatter plot. Does the scatter plot seem to support the statement that larger houses tend to cost more? Explain your thinking. Yes. Okay? Yes, it does. And you're going to hear me say this a lot too. As whatever the x-axis is increases, as the size of the houses increases, the price also tends to increase. Okay? So if we look here at the graph again, as this is increasing, what's our data doing? Okay, in general, is there a trend? Not perfect straight line, but these dots are all going up. Maybe not the same rate, but they're all increasing as well. Okay, so what is the cost of the most expensive house, and where is that point on the scatter plot? Well, the cost of that's easier to get the exact cost here, right? On the table, okay? Because here, now this is the downside to the graph, we can see that it's over 5,200 and it's right around $1 million, but we don't have this exact information like we do here. So what is the cost of the most expensive home? Well, it is $1,050,000. Now, where is that point on the scatter plot? Well, where is that point? Well, I'm going to just say this. It's at the point 5,232, 1,050,000. If they want a point, it's right there, okay? All right, you get the idea with that one. Now it says estimate the cost of a 3,000 square foot house. Okay, so approximately, if I look at the table here, well, isn't it hard to make an approximation? I'm like, well, it's probably less than this one. There's no other 300,000 one, so I could go maybe to a, well, 2,400 square feet, so it's gonna be somewhere in there. If we look here, here's 3,000 right here, right? So if I looked at 3,000 here and kind of went up and maybe kind of like go in the middle here, right? I don't know. We say 2,000, how much are they going up by? I don't know. I think it's like 40,000, right? So if I said it's in here, maybe it's like 320,000. I don't know. Something like that. Oh, I know, I'm sorry. We're up here a little ways. So maybe 380,000. Okay, again, it's hard to just estimate. So, do you think a line would provide a reasonable way? So, do you think, looking at this data, that there's a relationship? Remember doing this in the last lesson. And if there is a relationship, do we think it's linear? Like, could I put a straight line here? And then is it positive or negative? Okay, well, I do think a line would be kind of fitting to this data. Kind of our lesson title, right? Informally fitting a line. So I do think a line. So do I think a line? Sorry. Yes. Yes, I do. Okay. How could you use line to predict it? Well, I could just find a point on the line, right? That's something we've been doing, right? We have X and Y values. The point makes, that line, we can write slope intercept form. I can do all those things that I've already been doing with a line. Bunch of dots, that's hard to do. So the next part says, well, draw a line that you think would fit the trend in the data. So this is the tricky-ish part, okay? We need to draw a line that fits the data. So this is the smallest point and this is the biggest point. And sometimes people think that we need to draw a line kind of like that, okay? Now, if you kind of glance at it, it's not bad. It really isn't. I don't know if it's the best fitting line though. Maybe you want to go through a majority of the points. Okay, so most of them are lying right here, right? So what if we did something like that? Okay, well, these points are all bunched around there, but it's not really representing these. Okay, so it's really a balancing act to try to draw a line that really represents all the points. Okay, and we talked about outliers. So we really don't want to take, and there's no real outliers in this case, maybe these, but not really. But you really want to try to get a line that represents as many points as you can. It won't be all of them, but as many points as you can. Okay? So when I draw that line there, what is the prediction of the price of a 1,500 square foot house? Well, 1,500 square feet. 10, I don't, 200, 400, 1,500 would be right here, right? Halfway in between. And it looks really to me like that would be at about, if they're going 40, 80, 120, 160. Okay. To me, it looks like it would be at about 160. 160,000, I should say. Okay. I can get that from my line. Now, that doesn't necessarily mean it's the right thing because do we have a 1,500 square foot house? No, but we have like almost 1,500 square foot house, and you'll see that that one's up here, isn't it? So it's not going to be exact with your measurements. But at least when we have a best fitting line, we can write an equation, we can make some predictions. Okay? And if you gotta have data, you gotta use data. If you're gonna collect data, you gotta use it to drive what's happening next or to learn about something. Okay? So consider the following general strategies. Okay? Do you think they are a good representation for drawing a line that fits the data? Explain why or why not. Well, for the sake of time, we might not go through all of these, but we have 4 right here. Okay. And it says, Laura thought she might draw a line using the very first point and the very last point. Okay. Not bad. That's not a bad thought, but it doesn't always work. Doesn't always describe the points. Okay. Phil wants to make sure that he has the same number of points above and below the line. Well, it's not a bad thought again, but what about outliers? Right? What if you had 2 outliers and you're taking them into consideration? Sandy thought she might try to get a line that has the most points right on it. Well, that could work. Okay. If I had a bunch of points here, okay, and what we might do is we might draw a line because this one here is going to get the most points on it, but it's not really describing all the data. Okay. So we could say it could work, but it doesn't mean sorry, writing sloppy as always, mean the line fits the data. So Marie decided to get her line as close to as many of the points as possible, and I think this really is the best idea. And I'm sorry I can't tell you there is an exact way to do it. So let's try to think of just this last one here. Try to get your line as close to as many points as possible. Okay, and sometimes it takes a few tries. You're gonna draw a line, you're like, that's not quite it, and you're gonna draw another line. Okay, but the best advice I can give you in drawing a line of best fit is to try to get it as close to as many points as possible.